Okay. Um, Two things. One specifically to Cashify, who I'm replying to. You're misinterpreting the implications you hope to press with this evidence. Okay. First of all, I've said a million times. I think will is unconscious. That's why. The will is that process of creating that energy. The consciousness is just like a readout room in a navigation center that's trying to say, hey, there's an iceberg there. Hey, there isn't there. And it only sees the top level stuff. It doesn't pay attention. It doesn't micromanage the will, right? Those muscle movements, the muscle nerves are connected to the brain. That is you starting to act. The fact that you could change it at the end when it does get conscious, you might have already started, and then you're like, oh, I don't have to attack. Okay. 2,000 seconds, that's contradicted by the video you gave. 2,000 seconds, so 2,000 milliseconds rather. 2,000 milliseconds is 2 seconds. So those ping pong guys, they were thinking about moving 2 seconds before. Well, yeah, they're in constant motion, right? But to hit that actual ball involved this parallel processing thing. So the other thing is just this idea that everybody else has. This isn't so much Cashify's angle on this because he's coming from a totally different angle, I think. But this belief in determinism is faith. You've lost the science that suggested it. Where's the evidence now? You have no evidence. In science, oh, well, look, one thing falls to another. No, in science, if there's millions of things, they follow a pattern. And if that pattern interacts with another pattern, it will result in yet another pattern of millions of things. If you talk about just one thing, an actual thing, not a billion little magnets all clumped together, but just one, then they act, like these probability waves with probabilistic distribution. So that means that the higher level thing of how you can determine something is an approximation. What we really were determining was the shape of these idealized curves, which actual events will hover around but not fit exactly. It's not complicated. You lost the determinism. We went deep. It looked determined, and then it looked indeterminate. Now, it might look determined again. That's why I told you guys a million times. For example, the multiverse example is reclaiming a kind of determinism, right? Because then there's no spontaneity. There's all the results happen that could happen. But you won't cut out free will that way. You don't get back to classical determinism. Why? Because we only experience one of those results. And so the navigation between which result we discover, there's still room for free will. Nobody has any evidence against free will or for determinism anymore from physics. Granted, you have it from your intuition. If you're an intuitionalist and you believe that your inner intuition of how things must be is the way they are, why else would you have that feeling? Then fine. Or maybe you could create a nice formalized system that is, in its own right, some sort of just as great as physics. Fine. And then it has to match reality, which physics does. So, you can create your own models, and that's the thing. Some people have there is a model. David Bohm created a model, or Bohm, I don't know, created a model that has the hidden variable idea. It's all deterministic, but there's this hidden variable I can't see. But it violates locality. So you have spooky action into distance. You're not getting back the common sense thing. We've already checked the common sense predictions. In the two-slit experiment, the common sense classical, it's not really that common sense, but the nice classical version predicts there'll be two bright spots and then they'll fade out because some of the particles will bounce around and there's some randomness because of that physical classical randomness, and it'll fade out. We don't get that. We get the bars and then we get other bars and dark spots. Okay, so the old model predicts that picture and the picture's inaccurate. Boom, old model inaccurate. There's no going back to that. There's going on to something that reclaims determinism, but then you lose positivism. Okay, you lose object realism just by the fact of the wave nature, the fact that there's a wave nature to electrons. See, that's the main thing. If you really want to rewind to the experiment, then what you have to deal with is the fact that if you shoot electrons one at a time through two slits, you get an interference pattern. That's wave behavior because the wave front will hit both slits, go through, and interfere with itself. But particles don't do that. The idea of a particle, it would just go through one thing. So seeing this wave behavior, that's what you have to face. In what sense, the electron looks in every way like it's a particle. It's an idealized particle practically. and it acts like a wave in this circumstance. How? You have to explain that. It acts like a wave. You could say, well, there's this other phenomena that really isn't a wave, but it's like, well, okay, yeah, because saying it's like a wave is only a rough approximation. You know why? Most waves, all waves we know of, it's like water waves. They have to go through a medium, and the physics of the medium is involved. The light goes through an electromagnetic medium. But it gets really weird. What is the medium of the quantum? Well, it's just some quantum probability field. It's some field that maps to probability. Even an electromagnetic medium is weird because it's not at rest. It is at rest with every observer, the electromagnetic field. You can't, in water, if there's a wave going on 100 miles an hour and you fly 200 miles an hour, you go faster than the wave. With light, it's always going faster than you. So the electromagnetic medium is weird. You don't have a relativistic, you don't really have a velocity relative to it. So it's already like these. So when we say waves, we study water waves, and there's a lot of different water waves change speed based on their wavelength. Okay, they're in a lot of ways not like electromagnetic or quantum field waves, but it's wave-like because a wavefront, the whole ripple hits the screen, and it can interfere with itself. That pattern you see, because there's a lot of study of waves just in classical wave dynamics and optics. You can study waves, and it's like, oh my God, I recognize that pattern. That's a wave-like pattern. When you're dealing with waves, you see those kinds of patterns. So hint, it's a wave in some sense, or just like a wave. It's something that comes out acting like a wave. And you have to deal with it. That's what you have to explain. How does one particle act like a wave and yet produce just one particle's worth of spec every time? You get a spec. So it also acts like a particle at the very same time. One little speck at every time. When it all comes out, thousands, the pattern emerges. The pattern, the determinable part. What pattern is it hovering around? That emerges, and you see an interference pattern. And you say, well, how could one go through, create one event on the other side, and create a wave pattern? Well, that's where they get to the probability. If it's a probability wave, then it hits both, goes through, and when it hits, the probability is still just one. You roll the dice, there's a probability pattern to it, but in the end, one of the numbers comes out. So, anyway, those are the two reactions on it. There's a tremendous amount of faith involved in any determinism because, you just can't use science. That's like using the four elements against chemists. Oh, I don't believe you about the base and acid thing because it's not, we know you guys say the elements are fire and earth and water and air. They don't say that anymore. They did at one point, but no, now you'd have to have your own argumentation, which you can have, but where's it going to come from? Don't claim it's from physics. That's 100 years out of date. When you look close enough, it only seems deterministic because there's millions of things, and that brings the law of averages in. You want to get back to your determinism? Do what I did and study this law of averages and probability. Study what it really means. Don't assume. You guys that think random means any one of the things could happen. No. If that's what random means, then that random doesn't count. That's not what we're talking about in quantum mechanics or even classical physics. There's random distributions. It's about statistics and stochastical distributions. It's like why you can make a deterministic algorithm that still creates one of these things that looks random, because it's about the distribution. So it's not like we can't determine things about reality. It's just that we determine them about groups of things. We make statistical statements about groups of things. You can't say something for sure on one experience, really, even though logically you can formulate there exists an experience like. But really, empirically in natural philosophy, you need lots of experiences. And it turns out each of these experiences has billions of events going on in it. And that's what you need to have this appearance of things that look like they're very consistent and determinate as things. But they're made up of things that don't behave that way. And the link is the law of probabilities and the law of odds. So just study that, and you will get back to your feeling of how you can be sure of something. How playing the odds is good enough. You don't have to be certain. It's not certain what your future is, even though the odds are it'll be this or that. Okay. All right, cheers.